Welcome back to statistics. We've seen how z-scores are closely related to the proportions and areas under the normal curve that you calculate when dealing with the normal distribution. Now we'd like to explore that connection in a little more detail. So more on z-scores and normal distributions. The connection between z-scores and proportions means that essentially any normal calculation can be converted to a calculation involving z-scores and the standard normal distribution. So here, for instance, you see a calculation regarding the distribution of IQ, which is normal with mean 100 and standard deviation 15. And in the figure, you see that we've calculated the proportion of scores that are no more than 115. Turns out to be about 84%. Now, that upper bound of the left tail at 15% has a z-score. It's actually 1, right? Because it's 1 standard deviation above the mean. Now, z-scores are associated with the standard normal distribution. So if you put that z-score corresponding to 115 in the standard normal distribution, and then compute the area of that left tail, you get exactly the same result, 84.13%. This correspondence holds essentially for any kind of normal calculation. So for instance, here's a different one in which we're looking at height, normally distributed with mean 68 inches and standard deviation 2.5 inches. And we've calculated the proportion of heights that are between 64.25 and 73. So again, if you convert the endpoints of that region to z-scores, and then look at the corresponding area in the standard normal distribution, you get exactly the same value, 91.04%. So this shows that any calculation involving the normal distribution can always be reduced to an equivalent calculation involving the standard normal distribution. This means that all normal distributions share some properties regarding areas and proportions. And sort of a shorthand version of this goes by the name of the empirical rule. The empirical rule looks at the proportion of a normal distribution that lie between plus or minus 1, 2, or 3 standard deviations of the mean. So here you see a general normal distribution, mean mu, standard deviation sigma. And if you look at plus or minus 1 standard deviation around the mean, so that would mean from mu minus 1 sigma to mu plus 1 sigma, you find that the area is 0.6827, and that's true for any normal distribution. So about 68% of any normal distribution lies within 1 standard deviation of the mean. If you look within 2 standard deviations of the mean, that area turns out to be 95.45%. And again, this is true for any normal distribution. And looking between mu minus 3 sigma and mu plus 3 sigma, in other words, at values within 3 standard deviations of the mean, you find that 99.73% of the values lie in that range. So the empirical rule is kind of those 3 benchmarks, 68% approximately within 1 standard deviation of the mean, 95% approximately within 2 standard deviations of the mean, and 99.7% within 3 standard deviations of the mean. And again, this holds for any normal distribution. We can also think about the quartiles of a normal distribution. So these would be the 25% point and the 75% point, right, for Q1 and Q3. If you look at the standard normal distribution, the quartiles turn out to be a minus 0.6745 for Q1 and positive 0.6745 for Q3. So the middle 50% of the standard normal distribution lies between Q1 and Q3, that is minus 0.6745 and plus 0.6745. That would say that the IQR, the interquartile range for the standard normal distribution, is 1.349, the length of that middle 50%. So the IQR, which is a measure of spread, is about 1.349 times the standard deviation, right, which is 1. So the IQR is a little larger than the standard deviation for a normal distribution, at least for the standard normal distribution. What about any normal distribution? Well, there, the IQR extends from mu minus 0.6745 sigma to mu plus 0.6745 sigma. So that would give us Q1 and Q3, and the middle 50% is in between those two values. And the IQR for any normal distribution is about 1.349 times the standard deviation. So the IQR for any normal distribution is about 35% larger than the standard deviation for that same distribution. So those are a few more facts relating z-scores and normal distributions. We'll have more to say about normal distributions, sampling distributions, and inferential statistics going forward. In the meantime, if you have questions, let me know. Y'all take care, and I will talk at you again soon.